Welcome everyone. In this video, we'll use a Hess cycle to work out an unknown enthalpy change. Question details are in the description. Let's get started. Here's the question. Anhydrous magnesium chloride, MgCl2, can absorb water to form the hydrated salt MgCl2.4H2O, and we're given the balanced equation MgCl2 solid plus 4H2O liquid gives MgCl2.4H2O solid. Suggest one reason why the enthalpy change for this reaction cannot be determined directly by calorimetry. If we look at the state symbols, we can see that anhydrous magnesium chloride, MgCl2, is a solid. Hydrated magnesium chloride, MgCl2.4H2O, is also a solid. Some chemical equations are theoretical. They don't represent what is likely to happen in the real world. To address the question, when water is added, it is difficult to prevent the MgCl2 from dissolving. You could also state that it would be difficult to measure the temperature change of a solid. Here's the next part of the question. Some enthalpies of solution are shown in the table. Calculate the enthalpy change for the absorption of water by MgCl2 solid to form MgCl2.4H2O solid. It is a very good idea to memorize as many definitions as possible. These definitions often come up as questions in exams. There are lots of definitions to memorize for enthalpy changes in thermodynamics. Examples include standard enthalpy of formation, standard enthalpy of combustion, standard enthalpy of hydration, first ionization energy, second ionization energy, first electron affinity, second electron affinity, and standard enthalpy of lattice formation. Post in the comments if you can think of any more. Enthalpy of solution is defined as the enthalpy change when 1 mole of an ionic solid is completely dissolved in water to create a solution of infinite dilution under standard conditions. For this question, if you know the definition, you will be able to draw the Hess cycle correctly. The Hess cycle is shown here. The reactants and products both point towards 1 mole of aqueous MgCl2 based on the definition for enthalpy of solution. It is a good idea to label each enthalpy change. This will ensure that the working out is clear. I have used delta RH, delta 1H and delta 2H. We need to find delta RH. Hess's law states that the enthalpy change of a reaction is independent of the route taken. The two possible routes are shown with the green and yellow arrows. The green arrow is equal to delta RH. The yellow arrow is equal to delta 1H minus delta 2H. So why do we subtract delta 2H? Enthalpy changes are vectors. They have magnitude and direction. Delta 2H represents the enthalpy change from MgCl2.4H2O solid to MgCl2 aqueous. The yellow arrow goes with delta 1H but against delta 2H. When we apply Hess's law to this cycle and express it mathematically, delta RH is equal to delta 1H minus delta 2H. Remember that each Hess cycle is different. The arrow associated with each delta H must point in the correct direction based on the standard definitions that you are working with. Finally, input the data from the question and take care when dealing with negative numbers. The final answer works out to be minus 116 kilojoules per mole. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.